So this problem gave us a visualization of what we're trying to do, except it's surface area. Okay, so I thought this was volume. Let me get the surface area formula. Here's the surface area formula when we're revolving around the x-axis. So our limits of integration are going to be from 1 to 4 since it's with respect to x. And so it's 2 times pi times our function of x, which is the square root of x. And it's times the square root of 1 plus the derivative of f of x squared. The derivative here is going to be 1/2 x to the negative 1/2 when the power rule is used, which is the same thing as 1 over 2 square roots of x, right? Because you can make that power be positive by putting it in the denominator. So we've got 1 over 2 square roots of x that's being squared. So we can simplify inside the radical. I'm actually not sure what we're going to do. Yeah, because I don't see a u substitution yet, but let's simplify the radical. Maybe I'll see something. Well, this is the square root of x. That means we can multiply inside here because they're both square roots. And then this is being squared. So this is 1 over 4x because square root of x squared. Okay, actually this is going to simplify nicely. Because the square root of x times something else inside a square root, we can distribute x to both terms. X plus 1/4 now, because x times something over x, they would cancel out to make 1. So we get that u be the inside, du would be, we've got du. Yeah, that might be easier. Let's just use u substitution. You might be able to puzzle this out with u substitution, but I'm just going to let u be the entire inside of that radical. It means du is 1, which we have, right? So we can rewrite this in terms of u. Limits of integration have changed, though, so I'm going to drop those temporarily. So the square root of u du. And that one just needs the power rule in reverse to find the antiderivative. That's a 1/2 power, so the power is going to go up to 3/2. Then to compensate, we need to multiply by 2/3. That way the derivative would turn back into what we wanted it to be. But we need to evaluate this using our limits of integration. So I'm going to put this back in terms of x. We evaluate that from 1 to 4. Okay, so if I plug in the upper limit of integration, 4, that's 4 plus 1/4, so that's 16 over 4 plus 1 over 4, so that's 17 over 4. Oh, they probably don't want me to round, do they? What question is this? I think this is question 9. No, they want the exact answer, so that's going to make it take a little longer, but we can do that. So we plugged in 4, that got 17 over 4. I'll show you how to evaluate that to the 3/2 power without a calculator. And then we're supposed to subtract what happens when we plug in 1. So that's 4 over 4 plus 1 over 4, so that's 5 over 4, evaluate to the 3/2 power. Okay, calculus is done, now it's just fraction work. So 17/4 to the 3/2 power, that's the same thing as 17/4 squared over the square root of 17 over 4. Right, because those powers would subtract since the bases are the same. So 2 subtracted by 1/2 makes 3/2. So same thing over here. Brutal though, huh? Man, I really just would rather use a decimal. Let me see if it'd do. a decimal. Let me pause the video. Let me see if it'll take a decimal, because this is just so much work that doesn't involve calculus. So I'm going to back up. I'm going to use decimal approximations, see if Webassign will accept it. I'm very sorry. Webassign will not accept decimal approximation, so we have to do it this incredibly long way. So the numerator up here, that's 289 over 16. And then down here, we're dividing by this square root, right? So we could say that's flipping and multiplying. So that's times the square root of 4 over 17. Let me double check my logic there, because you would be dividing by. I think it's the same thing. So over here it's 2/3, and then we've got the 5 over 4 squared in the numerator, so that's 25 over 16. And then we're dividing by the square root of 5/4, so it's the same thing as multiplying by the square root of 4/5, I think. And I run out of whiteboard. Okay, so simplifying a bit more, it's 2 pi, and then this is the square root of 4 times the square root of 17. So with our numerators, we've got 2 times 289 times 2, that's 1156. In the denominator, we have 3 times 16, 48 times square root of 17. And over here, that's same thing. We got square root of 4 in the numerator, so 2 times 25 times 2, that's 100. The denominator, 3 times 16, so 48 square roots of 5. Craziness, just craziness. This isn't calculus. This is just complicated arithmetic. This is nuts. I didn't choose this question. I didn't choose a lot of these questions. In case you can't tell. So I divide the top and the bottom by 4. Top and the bottom by 4 again. That's 25. I should know that. So we can get common denominators by multiplying this fraction, the top and the bottom, by square root of 5. So 17 times 5. The square root of 85. And then top and the bottom by square root of 17. So now you can just make that one big fraction. This is 2 pi times 289 square roots of 5 minus 25 square roots of 17 all over 12 square roots of 85. Oh, and I guess these could reduce too. 2 and 12, that makes 6. At some point, I think you can just type in the exact answer and Webassign's still going to accept it, but I just kept simplifying. Let me prove it. I went and double checked my work in an online calculator too, but okay, Webassign. The numerator, I have pi times 289 square root of 5 minus 25 square roots of 17 over 6 square roots of 85. And accepted that. That's approximately equal to this that decimal answer you saw me type in before.